Starcloud is a space startup working on deploying data centers in space. They're the original company working on this long before AI compute in orbit became popular. The reason is simple. Earth's data centers consume enormous amounts of electricity to feed the power-hungry computer systems needed for AI training, plus large amounts of water for cooling. In space, there is practically unlimited amounts of power available from the sun, while the vacuum of space provides free cooling. Add to that no paperwork, licensing, environmental audits, and all the other bureaucracy that's needed on Earth. This is why the big tech companies building the most powerful AI models are looking to move AI training into space over the next decade. Elon Musk has stated that orbital AI training will soon be cost competitive with terrestrial data centers and provide the only realistic means of scaling AI compute to the level needed to stay competitive. Starcloud will initially target other satellites for their compute services. Later, with larger and more cost-efficient systems, they will compete directly against Earth-based data centers. Today, Earth observation and imaging satellites collect enormous amounts of raw data which is downlinked for processing. Once Starcloud's advanced AI satellites are operational, a customer's raw satellite data can be sent via laser link to their orbiting AI satellites for analysis. Key insights will be extracted using AI models and downlinked to Earth, greatly increasing the speed and relevancy of existing space assets. In November 2025, their first AI satellite was launched. It was only 60 kilos in mass and carried the world's first NVIDIA H100 GPU in space. This satellite, even though it was small and produced only 1 kilowatt of solar power, provided 100 times more powerful compute than any other satellite launched. This mission was a proof of concept that state-of-the-art GPUs can operate successfully in orbit, despite the challenging thermal and radiation environment. Starcloud are designing 40 megawatt orbital data centers weighing around 100 tons. Yes, you heard that correctly, 40 megawatts, not kilowatts. With upcoming super heavy lift vehicles such as Starship and the upgraded New Glenn vehicle, large satellites can be deployed in a single mission. Let's explore the different systems Starcloud is building. Starcloud 1. This single 60 kilo satellite, launched in November 2025, is still in orbit. It's fully operational, but is expected to burn up in the Earth's atmosphere sometime later this year. You can follow its position live on satellitemap.space. Just type in Starcloud-1 into search and press enter. In December 2025, Starcloud 1 ran a version of Gemini in space, the first spacecraft to train a large language model in space, although in this case it was only a small training set. With scaling, it's only a matter of time before gigawatt data centers will be training frontier AI models in space, using the free power from the sun and the free cooling from the vacuum of space. There really is no limit to how big these systems can grow. Now, let's look at the future Starcloud 2 system currently under development. Starcloud 2. Their next system will be a commercial satellite, named Starcloud 2. It will feature a GPU cluster, persistent storage, along with Starcloud's proprietary thermal and power systems in a small-sat form factor. This satellite will have at least 10 times the compute capacity of Starcloud 1, along with the largest commercial radiator in space. To carry the heat from the chips to the radiators, a coolant tube runs past the GPUs to a large deployable radiator that emits heat as infrared into deep space. Starcloud's two key pieces of innovation are very large, low-cost, low-mass deployable radiators to dissipate heat and making the GPUs work in a high radiation environment. Currently, out of a team of 11 people, 7 are working on radiators, with 3 radiation hardening the semiconductors used on the satellite. Starcloud 2 is expected to be fully operational in a sun-synchronous orbit by the end of 2026. As mentioned previously, Starcloud's first customers will be in-space users. It doesn't stop there though. Let's look at the even more powerful Starcloud 3 system, only recently announced by Starcloud. Starcloud 3. We heard about this only recently from an ex-post by Starcloud CEO Philip Johnston. He said, "For the last several months, we've been working on the design of our Starcloud 3 distributed constellation of 200 kilowatt inference nodes in dawn-dusk sun-synchronous orbit, providing many gigawatts of low-cost AI compute. It seems we're not alone," unquote. Ezra Fielden, co-founder and CTO of Starcloud, added, 200 kilowatts of power, compute, and thermal dissipation in a flat sat package. Starcloud 3 will be an impressive machine and is designed to be deployed en masse to form a massive distributed inference cluster, unquote. This system should be on par with Elon Musk's planned AI satellites, which uses the Starlink version 3 platform, repurposed to perform AI compute rather than communications. Let's look at a blog article by their CEO on their company website. It's titled, "How Data Centers in Space Sustainably Enable the AI Revolution." In this blog article, and the link to it is in the video description, Philip Johnston explains the rationale behind orbital compute and addresses some of the challenges. He states that out-of-the-box solutions are needed to solve the problem of scaling AI compute when the cost of electricity is soaring. The US power generation has been flat over the last 20 years, while xAI's Colossus supercomputer has 1 gigawatt total capacity, with plans to double that soon. There is simply no way to scale the compute power needed, at least not on Earth. US data centers consume around 25 to 30 gigawatts in 2025. Forecasts show a massive increase, potentially to 90 gigawatts or more by 2030. Boosting power generation and distribution is difficult because of the many bottlenecks, not just power stations, but permitting delays, transmission constraints, water for cooling, and local opposition all slow things down. For instance, a single 40 megawatt AI cluster on Earth consumes over 1 million tons of water annually for cooling. In short, AI training clusters cannot be scaled on Earth, at least not fast enough to remain competitive with other places like China, which don't have the same constraints on the environment or permitting issues. The Starcloud CEO goes on to explain that many of these Earth-based constraints don't exist in space. Placing AI satellites in a dusk-dawn sun-synchronous orbit gives abundant power, close to 24/7. Solar power in space is more intense than on Earth because it doesn't have to travel through the Earth's atmosphere and is not blocked by clouds and absorbed by rain. Next, he writes about the free radiative cooling AI satellites get from being in a vacuum. You can think of space as a giant heat sink, with space at a temperature of minus 270 degrees Celsius. Simply add radiator panels to the satellite to remove waste heat. That's it. No need for water cooling or complex pumps or machinery. AI data centers in space are, from an operational point of view, simple and easy to run. Another huge advantage of space is scalability. There are no practical limits to the size of a fleet of AI compute satellites. Rather than building a single large system, many smaller satellites are deployed and linked together with high-speed optical links, similar to how Starlink satellites currently work to route messages around the planet. Challenges. Let's look at the challenges and how Starcloud plans to address them using Philip Johnston's blog post for guidance. Orbital debris. Space is full of orbital debris, with approximately 10,000 tons of defunct satellites, spent upper stages, and debris orbiting in chaotic patterns at enormous speed. Starcloud satellites are designed to burn up completely in the Earth's atmosphere after their mission is completed, which is around 10 to 15 years. It's noteworthy that SpaceX plans to send their satellites on a heliocentric orbit, that is orbiting the Sun, not Earth. This is necessary because their plans include deploying 1 million satellites, which would cause too much pollution if they re-entered Earth's atmosphere. With Starcloud, for the moment, only committing to operating a few satellites, there is no need for a heliocentric disposal orbit. Radiation. Sensitive components such as GPUs need to be shielded from radiation to prevent data corruption. The satellites will operate within the Earth's magnetic field, so will be shielded from the bulk of the radiation from the Sun and the constant cosmic background radiation. The Starcloud team are working on radiation hardening critical components on board the spacecraft to handle the radiation environment. Competition. The biggest competitor we know of at the moment is SpaceX. Elon Musk has made it clear that he plans to construct massive data centers in space. Other tech companies working on orbital AI are Google with their Suncatcher project. Their plans include teaming up with Planet Labs to deploy satellites running their custom-designed Google TPUs, or tensor processing units, connected by optical links. They're targeting early 2027 to test the hardware, radiation effects, and distributed machine learning in space. I've reported on Etherflux's Galactic Brain project already. This space startup is working on beaming power down to Earth from satellites, and have now branched out to include orbital compute with this new project. They're targeting Q1 2027 for their first commercial satellite. Axiom Space plans to deploy orbital data center nodes or modules. They have already launched on SpaceX's Twilight mission 2 free-flying nodes, marking their first step into orbital computing. The Chinese have already started to deploy their 3-body computing constellation, which will eventually grow to 2,800 satellites. This system is currently the most advanced compute platform in space, giving the Chinese an early start. It's likely we'll have announcements from Amazon and Blue Origin in the future, plus some smaller players, no doubt. Final thoughts. Starcloud already have their first AI satellite in orbit. Their second satellite is due to launch in October 2026 and will be at least 10 times more powerful, using NVIDIA's Blackwell architecture, more GPUs and high bandwidth optical terminals for constant connectivity. What do you think of Starcloud's plans for orbiting AI satellites? Can they compete with SpaceX and Elon Musk? Does first mover advantage help them to win in orbital compute, or will the established tech companies take over? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you've got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.